As I look at this, I'm thinking of some kind of a trig substitution as I see this piece of it. So I'm going to go ahead and draw a triangle, and I'm going to label the sides so that this ends up being one of the sides. So this is going to have to be my hypotenuse, and then this is going to be 7, so that this is the square root of x squared minus 49. So now if I figured out this is going to be secant theta is going to be hypotenuse over adjacent, and then I'm going to multiply the 7 over here. Now my dx is going to be 7 secant theta tangent theta d theta. So let's go ahead and do the trig substitution. I'm going to move the 3 out in front of the integral, and then I'm going to have the square root of x squared, so that's going to be 49 secant squared theta minus 49, and that's going to be over x to the 4th, so that'll be 7 to the 4th secant to the 4th theta, and then my dx, which is going to be 7 secant theta tangent theta d theta. Alright, let's see what we can do to simplify that a little bit. This is, I could factor a 49 out, and then I could bring it out in front as a 7. So that would leave me secant squared theta minus 1, and we know that's tangent squared theta. Square rooting that, that would leave me a tangent theta. Okay, now these two 7s would get rid of 2 of these 7s, so that would leave me 7 squared. So I'm going to bring that out in front, it's in the denominator. And then this secant will get rid of one of these secants. And so let's rewrite what we have. We have 3 over 49 integral of tangent squared theta, there's one there and there's one there, over secant cubed theta d theta. Now, in looking at what I might do with that, if I could rewrite this in terms of secant using the Pythagorean identity, then I can combine the secants. So I'm going to replace tangent squared with, using the Pythagorean identity, that is secant squared theta minus 1. Now, I'll put it down here, so we have 3 over 49 integral, and here I have secant squared theta over secant cubed, that's 1 over secant theta. But wait a minute, what is 1 over secant theta? That is nothing more than cosine theta. Now, taking this to the other term, negative 1 over secant cubed theta, then that's going to be negative cosine cubed theta d theta. Now, looking to see what I could do with this, I'm good here. Looking at this one, that is using that idea of splitting off one of the cosines and rewriting the other in terms of sines and doing a U-substitution. So I'm going to come down here at the bottom and just work that piece. So that is going to be cosine squared theta cosine theta d theta, and we do that because then we could replace this with 1 minus sine squared theta. And now we can go ahead and do our U substitution. If we let U equal sine theta, then du equals cosine theta d theta. And here we have integral of 1 minus u squared du. So we can integrate that and get u minus 1/3 u to the 3rd. So now let's go back up here and work our integral. We have our 3/49 out in front, and integrating cosine, that's going to be sine theta. And then here we have minus this cosine cubed, and then we figured this out here. We can now put sine theta back in for the u, but remember we're subtracting all of that. And so we have minus u is sine theta, and then distributing the negative will make, that gives us 1/3 sine cubed theta, and then plus our constant. Alright, let's see what we've got now. These will cancel, and these 3 here will cancel with this 3 here. So this integral is going to equal 1/49th. And then we have sine cubed. And so what we need to do is go back to our triangle here and figure out what sine theta is, and then we will cube that. Well, we know sine is opposite over hypotenuse, so square root of x squared minus 49 over x, looking at these sides of the triangle, and that's going to be cubed plus a constant. So final way we could express our answer, we could write this x squared minus 49 to the 3/2 power, writing the square root and combining with the exponent, over 49x to the third plus a constant.